So example 4, let's talk about applying functions. How can what we've learned today in this lesson, how can this be used to help solve real world problems? Well, the function y equals $1.75 minus x could represent the money that still needs to be inserted into the vending machine to buy an item that costs $1.75. So you're standing at the snack machine and you want something that costs $1.75. We need to figure out how much more you need to enter into the snack machine, how much money you need to add to it to get your snack, okay? So we're going to let X be the amount of money you've already put in the machine. And then we're going to use this function to show how much money you still need to put in the machine, right? And it says that X is going to equal 10 cents. It's going to equal 35 cents. So these are our input values. It's going to equal 60 cents and it's going to equal $2, okay? So do you see at the end of the word problem where it says let X equal, or when X equals, and do you see these 4 amounts? Okay, I'm going to write it like this because this is how we've been looking at it and it makes sense to us. These are our input values. Now let's figure out what the output is going to be. Okay, so I'm going to take my function rule, 1.75 minus whatever X is. If X is 10 cents, what's the output going to be? $1.65. What about if X is 35 cents? What's the output going to be? $1.40. What about if X is 60 cents? What's the output going to be? $1.15. And what about if the input is $2? The output is going to be negative 25 cents. So change needs to be returned back to the customer, right? Okay? So what we have done is called, are you looking at me? This is called evaluating a function. So when you read the directions in your textbook on a quiz, evaluate this function when X equals. Basically, they're giving you some input values. You got to figure out what the output is going to be. Now, example 4 did not tell us to write our response as ordered pairs. So we don't have to do that. Putting it in an output table is sufficient. A mapping diagram like this basically is sufficient. Or you could write all your results in ordered pairs. When I put 10 cents in, I still lack $1.65. When I put 35 cents in, I still lack $1.40, blah, blah, blah. Either way, okay? You could show your results like that. So let's look at our assignment. So for 14.3, we're going to do one through 11 all. Then we're going to do $12 through 22 even. And then we're going to do 23 and 25. And that'll be it.